And everyone, please help me welcome Marco Palladino. He is the co-founder and CTO at Kong. And today we're going to be talking about the new API tech stack, the future-proof of building the fabric to future-proof modern API architectures. And Marco, I love that term, future-proof.
Yes. Welcome, everybody. Can you hear me well?
Yes.
Perfect. Yes, thanks for the opportunity to be here. Today, I want to chat about modern architectures that can support our API expansion in the world. If APIs are going to become, and they are already today, the system of records for all the services and all the things, all the data that the organization has, that really makes the API infrastructure the brain and the spine for the organization. And reality is the brain and the spine of the organization is invaluable. It's what allows us to move forward and innovate with more agility and more speed. So let's have a chat about all of that. Before we do that, let's start by looking at the evolution of APIs. You can see that the concept of APIs, of course, it's not something that came into existence a few years ago. It's something that in reality, in one way or another, has always been present in our applications. But we can see that there is a big gap between 2004 and this new wave of API technologies that are starting to show up after 2011. And I really like to call these an API renaissance. So this is essentially a new API wave that has been driven by new use cases and by new applications and new technologies like mobile, for example. Steve Jobs goes on stage, releases the iPhone. Now, all of a sudden, the world is moving to build a digital applications that can run in our pockets. And all of a sudden, we need to be able to connect with our monolithic applications that up until then were running in a very siloed way inside of the organization. And so to do that, we start building APIs, the adoption of RESTful APIs against SOAP that anybody can use, that anybody can build on top of in order to then create this new connected world. APIs today really are at the backbone of anything that everybody's doing, and it is what powers our digital world, which, by the way, it's a bigger part of the world that we're living in. Monolithic to microservices transition is also something that has driven more adoption of APIs. With the creation of Docker and Kubernetes in 2013, 2014, we now have an opportunity to build better applications that can drive more business by transitioning them into decoupled services that, quite frankly, at the core, are just going to be having APIs that generate even more traffic internally to be able to deliver on all the applications that we are building. Of course, now everybody's doing this transition, and the transition to the cloud is also another big driver for this transformation. But let's take a look at why we are doing this, first and foremost. The choice of API infrastructure that we're going to be adopting in the organization, it is at the end of the day going to be supporting the outcomes that these transformations wants to achieve. And so what are these outcomes? Well, there are primarily three outcomes that I see very commonly being adopted when developers and architects move to microservices. First and foremost, we want to be able to have a more reliable type of applications that we're building. If the digital application in the digital world, it becomes a bigger part of our world, as we all know already, then these applications cannot be unreliable. They have to always work, always up and running. They always have to have a contingency plan to be able to have zero downtime. And monolithic applications actually are not really great at that. When the monolith is down, any part of that monolith is down, the whole application is down. There is no decoupling, there is no decentralization. Everything, all our eggs are in the same basket. So transitioning to microservices powered by all of these new APIs really allows us to build better applications that are highly available. We're going to be seeing later in this presentation about a few patterns like service mesh, for example, that can help us implement data center failovers or being able to always keep these APIs up and running. If we build better applications, of course, we have better customers, we can provide a better experience, we succeed in the marketplace. Then the second biggest reasons for deploying microservices is that with a proper API infrastructure, organizations are able to ship new products in a much faster way. That's the reality of it. We're going to be able, with the right infrastructure, to be able to leverage existing IP, existing services that the developers and the teams in our organization have created in such a way that when we want to build a new product, or we want to enter a new market, or we want to enter a new industry, for example, virtual reality, we don't have to build everything from scratch. We can leverage on the assembly line of APIs that we've built in the organization to build these new products in a much faster way. That, of course, creates enormous advantages in the work that we're doing. We're able to lower the time to market. We're able to create more efficiency in the way the teams are building new applications. But most importantly, with the right API infrastructure, we're able to drive consistency and security and reliability on all of these new products, regardless of where they are running, if it's single cloud, multi-cloud, containers, or even virtual machines. This is very important. Organizations that can nail this are going to be much quicker than organizations who do not have the right API infrastructure. So APIs, really, it's not just about the underlying technology. Really, it's about how we're going to be driving everything that we do. It's a much broader scope. We as architects, of course, have to understand this, because the work that we're putting in place to support the teams throughout these microservices and API transformation, at the end of the day, it is going to be generating these outcomes. And so we have to have a full understanding of what are the blockers that we need to remove to get to this acceleration in agility and acceleration in velocity. And then the third reason why we are transitioning to microservices, it's to get better scale and scalability with our products, which in a way also reconnects to the first goal, high availability. We're going to be having multiple services that are going to be consumed in different ways, because of course, each one of them is owner of its own domain model. And some of them are going to be quite important for the business. We need to be able to scale them quickly, efficiently across one or multiple clusters that we're running. And we need to be able to do that in a very targeted way. And with microservices and the decoupling and the decentralization that microservices bring to the table, of course, this is very easy to do. We can now independently scale individual components of our applications, and we can do that with better efficiency, because we don't have to scale the ones that do not need to be scaled to begin with. So this really gives us so many options in the way we can build modern products by leveraging all of these APIs. Now, understanding the use cases, it's quite fundamental, because without the right API infrastructure in place, none of these will be achieved. The API infrastructure that we are building, it is going to be supporting the transformations that we have today, but it's also going to be unblocking and unlocking all the APIs that we are going to be building in the next 5 years, in the next 10 years. When we look at what we're doing, we're not going to have less APIs in 5 years from now. We're going to be having more APIs. And so what is the right architecture we're putting in place today to support the organization, to unlock the organization, to be able to innovate at this velocity? This is why API architectures should not be seen just as a tool, but also as a fundamental part of the DNA of how we run and build our systems. It is quite fundamental. Choosing the wrong technology today is going to be harming, is going to have long-term repercussions in the next few years. This is just the beginning, of course. We're seeing APIs being essentially already the fabric of modern applications and modern products, and this is going to get bigger over time. And so, in order for us to understand what are the challenges that our teams have to deal with, we have to go through the same transformations they've been doing. Obviously, when APIs became a significant part of the usage and the adoption of our systems, with mobile applications and microservices down the road, we had to do that transition from monolithic to microservices. The traffic that we are able to accommodate and the protocols that the teams were using in these transformations also changed over time, right? We started with SOAP, we started with REST. SOA, by the way, it's this dream that is very similar to microservices, but with a fundamental different technology choice and technology adoption. The goal of SOA and the goal of microservices, if we abstract it down, truly is being able to reuse the APIs, being able to build these products in a faster way, having a system of record of all the services that we can consume. But then why did SOA fail and microservices and REST succeed? Well, SOA was fundamentally extremely complex to implement. It was quite heavyweight in a new world where being lightweight and being performant, like mobile, for example, saving bandwidth was a requirement. The tooling around SOAP was also counterintuitive to a whole new breed and generation of developers, front-end engineers, for example, that were trying to just easily consume APIs from their JavaScript client-side applications. SOAP and XML and all of that was extremely complex for them to adopt. It was not the right technology, it was too much heavyweight. And so this is when REST really came out as being the savior, for this type of use cases. Now, REST is also, RESTful APIs is not a spec. RESTful APIs is a set of best practices that are built on top of HTTP. So with that flexibility also came lots of confusion down the road, but then we're trying to now fix that confusion with JSON schemas and all sorts of tooling that we're now building to make things a little bit more predictable. Long story short, we had to transition away from monolithic to microservices, and the adoption of protocols also changed with that. Now, when we transition away from monolithic to microservices, the monolith, of course, is a single entry point for our API consumption, but microservices are not. Microservices have all sorts of different APIs that are being served perhaps by different teams and different frameworks that we have to access. We are going to be seeing connectivity at the edge, external to the organization, but also internal within all of these microservices. A few things change. The technology that we adopt have to change as a result of this. Because microservices internally have a lot more back and forth, performance matters a lot more. If we introduce any middleware within the microservices that adds too much latency, at the edge, we can fix that by having a CDN in front of our APIs and calling it a day. But within microservices, that's a much harder proposition. First and foremost, we don't want to have a extra hop in the network to make those requests that go either through a centralized load balancer. We want to have a decentralized networking infrastructure. We're going to be seeing this with Service Mesh in just a second. But also performance becomes much more important because latency compounds over time. We have a lot more requests internally than we have externally, which means that if we introduce a middleware that adds, let's say, 100 milliseconds of latency, well, guess what? Because it's not one request, it's multiple requests, that 100 milliseconds of latency will compound to an extremely large number that will make our end users and our applications extremely slow. In a monolithic app, when the app is down, when the monolith app is down, the application is down. But in microservices, when the microservices are slow, the application is down. Slow is the new down. We have to use different types of technologies that are not monolithic, they're not black boxes. We're going to look at this in just a second. So we have lots of access to these APIs, and guess what? That creates a problem. Number one, the clients who are consuming all of these services and these APIs, perhaps they don't need to have access to all of them. They don't need to be exposed to all the complexity of our microservices. And also, we want to be able to enforce an ingress point to be able to enter our APIs. And this is really why we want to introduce an API gateway that essentially gives us these nice entry point that the clients can use to be able to consume whatever service or whatever APIs we're running in the backend. Now, the benefits of an API gateway, it's also that it can offer a curated experience to API consumption. Typically, when we think of API management and full cycle API management, we think of that as an edge requirement that involves and affects primarily external consumers of our APIs, a developer community of our APIs, mobile applications. But really, we also want to run these internally. If I am a team consuming another team's APIs, I don't want to learn about all the complexity that runs those APIs. I just want to have a very curated experience internally as well to be able to consume these APIs. And so the gateway can allow us to enforce this main entry point that, yes, it provides networking level type of functionality like security, authorization, authentication. But most importantly, it offers a curated experience to the consumption of these APIs. APIs with no consumption are dead APIs. We can have 100,000 APIs in our organization, but if nobody consumes them, these APIs are just looking at each other. API management with a full life cycle, by treating the API as a product, allows us to implement a nicer experience when it comes to that. But this leaves us with a bigger problem inside our microservices. We have all of these requests that are going on the network, which by default are not secure, they're not reliable, they're not observable, because the network is not secure, it's not reliable, and it's not observable. And so how do we fix this problem? This is where patterns like service mesh can help. And so by adopting a service mesh, not only we have an opportunity to secure that internal network by providing automatic zero trust and end-to-end encryption, or being able to provide automatic tracing and observability and logging, automatic load balancing, and so on and so forth. But we also have an opportunity to make the life of our teams easier. By adopting and shifting all of these concerns into the infrastructure, we can remove them from the applications and the services themselves. This is invaluable. Now, the teams that are building the services and the APIs can really focus on building what they need to be building, the value proposition, the actual business logic they want to create, the applications for the end users, without having to worry about managing the network. Thinking that our organization can transition to microservices, and yet also thinking that our teams are going to be in charge of managing the underlying network, it's going to be making this transition unfeasible. We are essentially demanding the application teams to do something they should not be doing, managing and building the infrastructure. And so the gateway in the service mesh really allow us to remove these concerns from our services. And that is an opportunity to also make our services smaller, because now all this functionality that the teams would create in the services gets removed. It's being shipped by the infrastructure. That means that the developers are going to be creating applications in a much faster way, because they're going to be creating services in a much quicker and faster way. This accelerates the output that we as an organization are going to be producing by making everything faster and consistent, by having platform agnostic runtimes and technologies that we can deploy across multiple clouds, that we can deploy across multiple environments, not just containers and Kubernetes, but also teams that are not that far ahead in the journey, that are still running on virtual machines. We can create a consistent networking layer, a service overlay that can span across multiple areas and can bring that consistency without having different behaviors in different environments. This, again, improves our high availability. It improves our reliability in general, and it accelerates the creation of our applications. Again, everything that we're doing here, at the end of the day, must reconnect to the outcomes that we want to achieve. High availability, reliability, right? Quicker time to market, so we can ship faster, we can reuse our applications, and we can do all of this in a secure way. And finally, when we create a modern fabric for our teams that allows external traffic to enter the organization through a gateway, it allows us to deploy internal gateways that create a life cycle, a curated experience for the other teams inside of the organization. Once we introduce a service mesh that creates a service overlay, which makes the network, which is unreliable, makes that reliable. Well, now we have to work towards understanding how we can drive consumption to these APIs. Many times, I have the opportunity to work with very smart architects and teams that are hyper-focused the networking requirements they have within their own application. And just a few of them ask themselves, yes, but how are we going to be encouraging and incentivizing consumption of these APIs? Again, with no consumption, these APIs are fundamentally dead. There is nothing that we can do. There is no value that we can obtain if there is nobody using these APIs, either externally or internally. So how can we drive more consumption? How can we make it easier to design and test and collaborate on the APIs that we are creating? And this is a very hard problem. And this is what I call in this picture the API design and testing and collaboration function that allows us to make all of these APIs a lot more accessible to the end user. So the design and collaboration, the API gateway as a centralized ingress point that offers that curated experience, and the service mesh. These are the three main components that we have to build and think of when we build a modern, future-proof API architecture for our teams. Now, of course, I'm the CTO of Kong. So the reason why today I'm talking about all of this is because Kong is a company, a vendor that has been specializing in this particular problem. Kong offers a full stack suite of connectivity products that go from API design and testing with Insomnia through the gateway, Kong Gateway, and as well continue to the service mesh with Kuma Mesh. All of these are open source projects. I'm a big believer of open source as being a fundamental driver for this microservices transformation because it allows bottom-up adoption of software and also avoids the creation of black boxes in what is going to be the most critical part of the entire org, how we run the brain and the spine, the system of records of all the APIs that we have. Kong Gateway particularly, it's quite battle tested because we're running since many years, and today we process approximately 11.7 trillion requests per month. To give an understanding on how much that is, Netflix, which is a very good example of an organization in our industry that is API intensive and has built their own tooling to deal with the scale they're dealing with. Netflix, we can estimate them to consume approximately 0.6 trillion API requests per month. So worldwide, we could fit 20x Netflixes in the consumption that Kong Gateway does. And this is important because has made Kong Gateway quite battle tested and production ready. It never goes down. And the service mesh, of course, is one of the most successful products at Kong. It's actually growing faster than the gateway business. And it is something that we partner with our customers to make sure that this entire full stack from north-south to east-west, from API gateway to service mesh is being taken care of. The goal here is to accelerate the creation of these underlying API infrastructure that can unblock a new generation of applications in our organizations. Modern APIs architectures have evolved. If by now this was not clear, I hope it is now. I mean, we're dealing with fundamentally a different scale of problems than we have back in the SOAP era, back in the pre-SOAP era. This is a new way of building software and organizations that is providing us with a massive opportunity to change and shape what our organization is going to look like in the next 5 to 10 years. Now, in order to understand this evolution, I want to guide you through the steps, the practical architectural steps that we have to work with. Back then, when APIs were not as many, were microservices in a pre-microservices era, we were fundamentally adopting monolithic API management solutions. Most of the times, these solutions were closed source, they were hard to use, hard to expand, hard to deploy. Some of them don't even run natively in Kubernetes or containerized environments. And back then that was okay. They were adding lots of latency, but like I said, we could use a CDN in front and call it a day. APIs used to be an afterthought. We used to build APIs on top of the monolith to enable that communication with mobile applications, for example. Now, of course, as we shift towards microservices, APIs are not an afterthought anymore. We're building APIs since day one because that is what powers all the functionality of our application. Everything is API driven. In a world that's API first, we need to be able to adopt technology that's fast, that's quick, that offers us visibility into what's happening in our API infrastructure. So being open source and not being a black box is a big benefit to it. As well, being able to be highly extensible and extensible. This is why Kong Gateway was born, for example, to cater to this new generation of APIs that were born. Native to not only one environment, but multiple environments, Kubernetes, single cloud, multi-cloud, VMs as well. The goal is to support every team in this transformation. So if you are an architect in a large organization, you're going to be having internal customers that, yes, are running on Kubernetes and containers, and some others that are not there yet, different stages of their journey. And so we want to be able to support them by lifting and shifting the networking stack into a modern state so that their migration from legacy workloads running on VMs perhaps to modern Kubernetes containerized workloads, it is easier because then the network is one less thing they have to migrate and one less thing that they have to care of. And by having software that can run consistently across all of these environments, well, now we can target a larger amount of workloads in our organization, not just the new ones, but the old ones as well, where chances are that's where most of the business still runs today. And then finally, we want to be able to support the teams that are further decentralizing their applications into microservices to be able to provide a modern service mesh infrastructure layer. And this is why we built Kuma. We built Kuma because we considered the first generation of service meshes, primarily Istio, to be architecturally complicated, hard to use, hard to deploy. Lots of architectural changes that have happened throughout the years, and lack of support fundamentally to these service mesh made this whole migration a lot more complex. The whole point of technology is to help modernize. It's not to introduce a lot more problems that prevent us from modernizing. And so we wanted to build a service mesh that was powerful, built on top of Envoy, and yet easy to use. And that's why we built Kuma, which is a CNCF project that anybody can use. It's open source. We're working with CNCF to make these the easiest service mesh to use. So
thank you, Marco. We are running out of time and we do need to keep moving forward. I do want to say thank you again. And for our audience listening real quick, because I know your talks are always so inspiring, how do people reach out for more information?
Well, here it is. konghq.com is the best way to reach out to us and the community, by the way.
Awesome. Thank you so much for joining us today. And we look forward to hearing from you again. And again, it's Kong HQ to reach out and find out more information.
Thank you.